Okay, so with these optical devices, we're going to be starting primarily with mirrors, but right now we're going to kind of introduce the concepts to both of them. Before you plug into the outlet, I'm going to have you, we're going to use the snaky guy because last time we had, Angelique can attest to the fact that we had actual sparks coming out of the floor outlets at one point, so.
Just is like extra power to your computer.
Yeah, no, I'm like, let's not do that. Okay, so with the devices of the mirrors, okay, we're going to start with some basic terminology on this because terminology is everything, and getting this down is going to help like quite a bit. So let's start. Okay. Sorry, I now have my laser pointer out. So what we have here is an image of two different types of mirrors and two different types of lenses. Okay. Now, these are going to be marked up a lot, and we're going to use these a bunch. We're going to be doing drawings, technical drawings based on these, and in order to do that, we're going to need to use rulers. So you're going to be getting rulers for all of these. And we're going to be using, and the actual values, the amount of curvature here is important. So it's going to be incredibly important that you use the real ones, not just like quick made up ones, if you want to get good, reliable answers. Is that a fair way to say it? Okay. In your note packet, you're going to find that there are pages and pages and pages of these, what we call primary axes. Okay. And a primary axis is the main line running through the optical device, namely the mirror or the lens, and it contains both the focal point and the center of curvature. From a notes point of view, I would strongly encourage you to use the abbreviations F and C, and we're going to define focal point and center of curvature in like less than 5 minutes, so it's totally worth doing that. Are we good? Okay. The next thing we want to talk about is the vertex. This is where the optical device crosses the primary axis. So the primary axis is the center line here, and right where it crosses it, that would be the vertex. Okay. Sorry, that's, there we go. Forget it. Okay. Then we're going to define what F means. That's the focal point. Okay. And the focal point is where all the light is actually focused. Okay. The F prime, which is the virtual focal point, is where light appears to focus. So you will notice, hopefully, that the focal point and virtual focal point are actually indicated on the diagram for the lenses, but they aren't on the mirrors. Mirrors are meant to reflect, so the light should actually and will actually come in front of the mirror. The virtual focal point would be behind the mirror. Okay, and this is where we're going to take a quick detour and use the mirrors we have in class. If you are watching this and aren't in class, a really good way of doing what we're about to do is to just look, go to your bathroom mirror and look in your bathroom mirror, and we're going to talk about what we're seeing based on looking in a bathroom mirror. Okay, so what we're going to have instead of a curved mirror right now is that we all have planar mirrors, or a flat mirror like your bathroom mirror. Okay, and I want you to look in the mirror, and what do you see?
Myself, me, and the wall.
Okay, all right. Do you see actual you, or do you see mirror you?
Inverted.
No, you're not inverted. I'm like, inverted would mean upside down. All right, put your finger on top of your head. Right, put your finger on top of your head. Okay. In the mirror, does your finger appear above your head? Yeah, then you're right side up. That's called erect or right side up. Okay. Um, you're not inverted. But I was going to say, mirror you is an image of you. Yes?
Yes.
All right. Like without looking at mirror you, feel your face. Yes? Okay. Now look at mirror you and like touch your head or touch your face or something like that. And does it look like mirror you is touching their face or doing the type of thing? Okay. I know this sounds silly, but this is like kind of getting at this. Now, I want you to raise your right hand and look at mirror you and wave at mirror you with your right hand. Okay. Now, I'm going to stand in front of you, right? And I'm going to wave in what looks like I'm waving back at you. So take your right hand, wave. I'm being mirror you. Yes? Okay. Now, if I were to wave my right hand, do I look like mirror you looks like?
No.
No. Okay. Because mirror you is left, right, reverse. Okay. Yes, I get that, but it's called left, right, reversed. It's not called inverted. It's called left, right, reversed. Now, does anybody? Oh, you know what? Do me a favor. Can you find something that has writing on it? Doesn't have to be anything fancy. I'm like, equation sheets work well. Something with writing on it, and hold it in front of the mirror. Okay. Look at and read the mirror version of it, or look at the mirror version of it. What does it look like to you?
Absolutely gibberish.
Doesn't look backwards. Okay. All right, cool. You can go ahead and put this down. We're good for a second. Now, here's the real question. All right. Here's me. I am in front of the mirror. Yes? What do mirrors do? Reflect. So the light's bouncing off the mirror and coming back at you. Yes? All right. Where is mirror me or mirror you? Like, where is mirror you located? Is mirror you in front of the mirror? But I mean, look, if you're looking at it,
yeah.
Does it look like mirror you is just like on the mirror itself?
Yes.
I don't think so.
I don't know.
If I put my hand on the mirror,
like relative position, no, it looks like you're in front of it. Like there's a distance between my elbow and the mirror.
Yeah, like there's a distance,
yeah.
And doesn't it look like mirror me is actually behind the mirror, like inside the mirror?
Oh
yeah.
Oh yeah, because it's
like it's equal.
Like it's and mirror you appears to be as far behind the mirror as you are in front of the mirror. Okay. Yeah, you get the concept of depth from the way mirror you appears. And like, I'm sorry, I get that this is weird, that this is kind of trying to get at this. But here's my question: is any light actually going behind the mirror? You can check. Right? Look at yourself in the mirror. Like, use the mirror, hold it to you. Okay. Now face somebody else with the mirror. Let's turn. Okay. And now, just look over to the side. Does their image appear behind the mirror? Like, no. Oh my God, you guys are actually in unison, which is really creepy. Like, that was bizarrely creepy. Now, straight off. But the idea is that we've got so mirror you appears as if it's inside the mirror, yes? Which is where light can't go. So we're going to call that like a virtual image, a virtual kind of thing. But we'll get more of that later. Now, let's take a look at the focal length, or the distance between the vertex and the focal point. is called the focal length, and we're going to use that as a lowercase f. Okay. Now, this, because we're in the light unit, people ask reasonably, as far as I'm concerned, how am I going to tell the difference between f, the focal length, and f, the frequency? Two things. Number one, context. Okay. They're going to be used in very different contexts. Number two, units. What are the units of frequency? Hertz, absolutely. What are the units of lengths? Meters. If you confuse hertz and meters, that's on you. Okay. This is a little bit of that whole idea of with context. I mean, we live with the English language. Read and read exactly the same, but you can tell by the context which one is intended. Yes? Okay. So I'm like, you'll get it straight. It's not going to be a problem, but I'm sorry. It's the distance from the vertex to the focal point. And then we get to center of curvature. And center of curvature is another kind of like location-based idea. Center of curvature, otherwise known as radius of curvature, is twice the focal length. Okay. We've got twice the focal length, which is going to be our given equation. All right. So first up, we started with definitions for general optical devices. Next up, we're going to do definitions when it comes to images, okay, and classifications of images. So our images are going to be either real, where the light actually comes together, or they could be virtual, where the light appears to be. Okay. So to get the idea of a real image, I have something called a magical illusion kit, which is basically two curved mirrors. Okay. And because I'm me, we have an eraser. And because this one is so ugly, I keep using it. It's a demented looking witch eraser. It's not a nicely done one. So instead of giving it out, I use it for this purpose. Now, what we're going to do is come around and I'm going to have it kind of sit this on the desk. And what you want to do is just look at it from where you're sitting. Don't look in, you're not trying to look into it, but you're just trying to look at it, and you should be able to see an image of the eraser. Okay. Do you see it?
Yeah.
Point to it for me. Okay. Is the eraser there?
I mean, no.
Yeah, like the eraser is not floating in midair. Okay. Yeah, but the light is actually coming together. It's all the reflected light is coming together to create the image.
Like a hologram would.
Yes, it's similar to what a hologram would appear
That's my eyes.
Okay, like it's right about here.
It looks like it's back in there.
Okay, all right, yeah, we're looking at different angles, so that's
Yeah.
going to change it. Okay.
That hurt my eyes.
Okay, go to touch, grab it or whatever. Okay, and it's literally like it's literally. Yes, it is. And oh, believe me, we're going to keep getting more and more and more wackadoodle. And I'm saving some of this for when we have everybody here to get at the really wacky stuff, so that we have, or hopefully have more people here to do this. So, some features of a real image. First of all, we call them real because the light actually comes together to that point. Real images can be projected onto a screen, like you see in the classroom when anyone's using a projector. What you see on the board or the screen is a real image. If you're talking about a TV, it's a little bit different. Okay. but we're talking classic projectors. They're always inverted or upside down. Okay, inverted meaning upside down, flipped over, that sort of thing, but not necessarily left, right, reversed. And they appear on the correct side of the optical device. So mirrors are meant to reflect. That means the image appears on the same side the object is. If the object is in front of the mirror, the image appears to be in front of the mirror. Okay. For a lens that's meant to let light through, the image appears on the opposite side of where the object is. And virtual images, on the other hand, it is literally physically impossible to project them onto a screen. And you're like, I don't even know what that means. Okay. This is the bathroom mirror time again. Okay. A screen can be a simple piece of paper. Would you agree that if you look at the image of you in a mirror, it's literally impossible to find a location in the universe where you could put the piece of paper and have mirror you show up on the piece of paper? Because mirror you is not made up of light that's coming together. It's made up of light that appears to be coming from a specific point, but the light isn't actually there. Okay, so that's why we say it cannot be projected onto a screen. It's always erect or upright. Okay, it's always right side up. It's always the same orientation as the object, in other words. And if a mirror is meant to reflect, and the light's coming together, it comes together in front of the mirror. Where does light come together for the virtual image we saw with the mirrors? Where does mirror you live? On the opposite side, right? So virtual images appear on the wrong side of the optical device, or the opposite side of the object for a mirror, or behind the mirror, and on the same side as the object for a lens, or in front of a lens. Okay. We're going to play around for a second with our cameras and the concepts of left, right, reversing in mirrors rather than lenses. But that's not something that I'm going to expect the people who were not here today to go over.